So firstly, we'll finish off the notes for 3A. There's just this last slide, slide number 5. So just fill this in, please. So we've got 2 root 5, and we want to express these surds as a square root of a positive integer. So we want to get rid of this 2 out the front. So what I know is that if we put it under a square root, it would have to be 4 times 5, because 2 squared is 4, or you can think of it as the square root of 4 is 2. So that's square root 20. And then if we had to simplify square root 20, we'd go back the other way. So it's doing opposite to what we did in the previous questions. So when we get to 7 root 2, when the 7 goes under the square root, it becomes 49, because 7 squared is 49 times 2. So that's the same as the square root of 98. So that's all of 3A now that you can finish. But let's have a look at 3B, which is adding and subtracting surds. And this is good because it's just fairly logical. So when we talk about like surds are multiples of the same surd. So it's just like terms when you first started doing algebra. So something like square root 5, 2 square root 5, minus 10 square root 5. They're like surds and they can be added or subtracted. So let's have a look. Let's decide if these pairs of surds are like surds. Now this is a square root 3 and a square root 3. So are they like surds? Yes. So you go ahead, just stop the video and have a go at the rest of them and then see if you got them right. This one would be no, because this is square root 5, but this one is whole number 5. This one also would be a no, because there's no square root 2. However, this one would be yes, because they're both square root 6. They're both square root 3. Square root 5, square root 7, nope, they're different. This one, yes, because they're both square root 5. And this one, yes, because they're both square root of 7. So let's just remember some of our basic algebra, and you should be able to do these okay because we've just done it. So see if you can work out for question 2. Just have a go at A, B, C and D, and then you can watch the answers. 11x take 5x is 6x. 2x take 7x minus 5x. Minus 4 plus 21, 17a. And this one, 4t take 5t is minus t plus 2t is t, or 1t, but we don't tend to write the 1. So go ahead and see if you got those correct. Hopefully there's nothing too stressful yet. Simplify the surds, square root 48. So that's like we did in 3A. So you have to think of one of the perfect squares that goes into 48. So I'm thinking it's going to be 16 times 3. And that's the same as square root. 16 times square root 3. Square root of 16 is 4 root 3. So hopefully you've remembered how to do those. So with that in mind, we're going to simplify B part 1. Because what I can do is I can say, I know that the square root of 48 is the same as 4 root 3. Square root 3 plus 4 root 3, which is 5 root 3. For part 2, square root 48, we said that was 4 root 3. Take 7 root 3, which is minus 3 root 3. And for this third one, 5 times the square root of 48 is 5 times 4 root 3 minus 3 root 3, because this was 4 root 3. So that's 20 root 3 minus 3 root 3, which is 17 root 3. So you can see that what we did in exercise A is going to be handy as we go and do B. So let's have a look. I'm going to do A and B here and then get you to have a try at doing them once you've had a look at me do them. So 2 root 3 plus 4 root 3 is simply 6 root 3. And for B, I'm going to look at the like terms. I'm going to say these are the root 6s and these are the root 2s. So I'm going to do 4 root 6 minus 3 root 6 is 1 root 6, or just root 6. And then 3 root 2 plus 2 root 2 is 5 root 2. So can you have a go now at the two below and see if you get them right? Okay, so for A, 2 root 5 plus 3 root 5 is 5 root 5. And for B, we'll do the like terms. We've got the root 7s. 3 root 7 minus 2 root 7 is just 1 root 7 or root 7. And then I'm going to do 2 root 3 plus 5 root 3, which is 7 root 3. If we subtract, we just do it the same way. However, this is a little bit tricky, isn't it? Because this is root 2 and this is root 8. So they're not like terms. But what I do know is that we can write the square root of 8. Which of the perfect squares, I'll just write them up here, goes into 8? Well, I'm thinking 4 times 2. So I could write this as the square root of 4 times 2 or 2 root 2. So this one is actually the same as 5 root 2, take away 2 root 2, which is 3 root 2. And for B, let's have a look. We've got 45, 20 and 5. So I'm thinking I'm going to see if I can get them all as square root 5. So for the first one, 2 square root 5. Now how would I write 3 square root 20? Well, you'll go, which of these perfect squares goes into 20? And I'm thinking it's going to be 4 times 5, which is the square root of 4 times the square root of 5, or 2 root 5. So instead of writing 3 root 20, I'm going to write 2 root 5. And then for 6 root 45, I'm going to go 6. And what goes into 45? 9 and 5. So that's 6 times root 9 times root 5, which is 6 times 3 times root 5, which is 18 root 5. So if you didn't do your exercise 3A, you're going to be a bit troubled, aren't you? Because this becomes 2 root 5 minus, that should have been 3 times up there. That should have actually been 6. I'm not going to re-record this or cut it. You just have to fix it. So we've got 3 root 5 minus 6 root 5 plus 18 root 5. So 2 take 6 is minus 4, plus 18 is 14 root 5. And what I'll get you to do now for the Now You Try is I want you just to do those on your calculator, please. So if you could do them now, stop the video and I'll write up the answers in a second. The first one is 5 root 2. And the next one is 2 root 3. So hopefully you got that right. If you didn't, ask the person next to you and see if they can fix that up for you. And then we get on to 3C multiplication. So you've got the rest of this lesson now to work on 3B, which is adding and subtracting thirds.